Good morning, everyone. Welcome to the first session of this workshop. My name is Nanjing. I feel really honored to chair this session. Okay, this session is about open systems for model integration. We have two speakers in this session. Each speaker will have 35 minutes. 30 minutes for the presentation and 5 minutes for the questions. Okay, now it's my pleasure to introduce our first keynote speaker, Dr. Daniel Ellis from Brigham Young University. Dr. Ellis is the editor-in-chief of the Environmental Modeling and Software and Open Water. His research expertise includes hydroinformatics, water science, big data, and geographic information systems and hydrological modeling. His topic today is open source GIS on the web, introducing a comprehensive Python-based package. Okay, let's welcome Dr. Ellis.
Okay, thank you. First, let's do a sound check. Can you hear me okay? Thumbs up if you can hear me. Awesome, thank you. Great. Well, thank you for that fine introduction. I appreciate the opportunity to be here with you virtually in Nanjing, China, and to share this presentation with you. I was also quite honored to be selected as the chairman of this international workshop on open geographical modeling and simulation. Serve that duty by giving you this presentation today, and also by following up with any of you who may have questions about open geographical modeling and other questions that I can help with. I think there is some feedback, so I think there's a way I can do one thing here. I will mute myself. I will mute you. Okay, so I've muted you, so I think that'll stop the feedback. One more time, thumbs up if you can still hear me. Yes? Yes, okay, great. Thank you, awesome. Hopefully the feedback will stop. Okay, well, in any case, here we are, and yes, welcome to Nanjing. I wish I was there with you. I hope to be there with you maybe another time, and I'm looking forward maybe even in the coming year to come and visit China and carry on this conversation with follow-up discussions and workshops. Before I get into the technical content of the presentation, I would like to highlight the journal Environmental Modeling and Software. It was mentioned a few moments ago, and I'm presently serving as editor-in-chief. You have sitting in your midst one of the founders and the longtime editor-in-chief, Dr. Tony Jackman. If you haven't met Dr. Jackman, perhaps, Professor, could you raise your hand so they can see who you are? And also one of our longtime and revered editors of the journal, Professor Alexei Voinov. Maybe Alexei, you could raise your hand and let them see who you are. So if you have any questions about publishing in environmental modeling and software, you might talk to either of those gentlemen or also come and talk to me virtually. So just to highlight the journal, this environmental modeling software is fairly highly ranked and respected, and it's published by Elsevier, and we'd love to have your contributions. We're specifically looking for papers that talk about modeling the natural environment and that have focus on model integration and simulation and uncertainty analysis and those types of topics. I would also like to highlight a new open access journal, Open Water, that we're launching here in the US with a few colleagues that are part of the consortium of universities for the advancement of hydrologic science. Those of you that are doing things in the water domain and that are interested in open access, open models, open software, open science, and would like to publish in a new journal with maybe a little bit lower bar to entry, please consider submitting to Open Water. And there's the URL, openwaterjournal.org. I didn't give the URL for environmental modeling and software because you can simply search it on Google or Baidu and find it very easily. So this is me again with some graduate students at Brigham Young University. I wanted to highlight our institution and give you a little feel for what I'm looking at outside my windows. BYU is a campus here in the state of Utah, and we have done a lot of things here in the open geospatial modeling domain, such as developed this MapWindow software. MapWindow is an open source lightweight GIS that you can use on Windows computers And the code is written in a combination of Visual Basic and C++, and it's a GIS that you can use and reuse. Spatial is another open source geographic modeling system that is specifically intended for use in the Microsoft .NET environment. So if any of you build tools in .NET Framework, these are map components and legends and other tools that allow you to do GIS with all open source in .NET. Hydro Desktop is an open access, open source water-based geographic information system. And finally, the newest tool to come out of our shop is Tethys Platform, and I'll spend a little more time talking about that one here in a moment. But this is for building web apps that allow you to do geographic data analysis modeling. So speaking of maps and spatial data, here's a map of the US highlighting the state of Utah. I don't know how many of you have been to, well, I know a few of you have been to Utah, but there's Utah in red, and the yellow X represents where Provo is. That's roughly where I'm sitting right at the moment. And if we zoom in a little bit more closely, we can see the campus and the area around Utah. And the reason I'm showing this is I'd like to highlight something I always share with my undergraduate students, which is that one of these, which one of these is the question, which one of these is a data model, a spatial data model of Provo, Utah? And so ponder that question for a moment. Which one of these is a spatial data model? Well, of course, the answer is both of them. This just happens to be a GIS map, and this happens to be a digital photograph, but they're both spatial data models representing Provo, Utah. Neither one of them is the real Provo, Utah, is it? However, the second one seems to highlight certain things, the buildings, the grass, the mountains, and the first one highlights the location. So spatial data is important. It's important to understand the limitations of your spatial data and your spatial data model, as well as its capabilities. Well, let's take advantage of this particular view of Provo, Utah, and I'll show you where the engineering building is. And out of the engineering building, this is where we've done a lot of these map software tools using Map Window and Spatial. And we've been fairly successful. Some of you may recognize the Netherlands there. In creating these kinds of tools and deploying them as standalone apps for different people to use in different ways. The last one is a web-based app using the Tethys platform. Now, as cool as all of this stuff is, and I think it is very cool, BYU is only a little bit known for these kinds of tools. It turns out that there's another building on campus that we are more well known for. And that building is over here on the left hand of the screen. It's the football stadium. Unfortunately, football gets more credit than engineering at some universities. And I won't say that's entirely true at BYU, but it sure gets a lot of credit. So let's talk about football for a moment. Here I am with my son at the BYU football stadium. And as you look at this picture, you'll see 60,000 people in the audience. And you will notice one thing. Well, you'll notice a few things, but one thing you might notice is that every one of them is wearing white, except for me. That's just random. So I'm going to pause every few minutes because since I can't get your feedback, I'll stop every once in a while just to make sure you can still hear me and everything's cool. Tony, I can see you very well, so you just wink at me if we're all good, right? Okay, awesome, thanks. Well, here's another view of that football stadium with the 60,000 people in it. And every one of these people at this moment is thinking the exact same thing. And maybe more importantly than where did I park my car, they're also thinking, how long is it going to take me to get out of this stadium and find my car? They might be thinking of a lot of other kinds of questions. What are we going to have for dinner? Is it going to rain? Where shall I find a new apartment? Which roads have the least traffic? Maybe they're wondering this: how far is it to Nanjing, China? It's possible. They're thinking all of these things, and all of these questions have one common feature. They can all be answered with apps that are map-enabled, whether it's a Google map or some kind of a food locating map, or Waze. I don't know if you have Waze in China. This is a way to help find the least traffic between 2 points. Zillow for finding apartments. Travelocity is a great tool for international travel, or a nice radar map. Every one of these takes advantage of the app paradigm of software development and maps. So let's look at another web app, another app that takes advantage of maps quite extensively. Some of you may recognize this particular app. This is Google Earth. Now, Google Earth is kind of cool because we can type in the place anywhere in the country or in the world and spin the globe and find our way into that place. So here we're going to leave BYU and find our way to Nanjing Normal University, where you are all at the moment. You might be saying to me, hey, Dan, that's pretty cool, but that is a commercially provided application by a commercial company, and this is a conference and workshop about open data and open modeling. How are the two compatible? Well, it seems that they are a bit compatible. First of all, if you look in the subtext at the bottom of the map, you will see that the bulk of the data that we're looking at is coming from open access data sets, such as US government websites, Landsat, and also the European Copernicus satellite mission, which is all open access data. Open geospatial data, and also these tools are function thanks to open standards and libraries. And without these open standards and libraries and open data, none of the, I would say that none of the apps that we've looked at or mentioned would work. Let me show you how you might build your own desktop application using the Spatial. It's going to give you some groovy music in the background. I'm going to zoom this in. And I'm going to do it on high speed. Some of you may use the Visual Studio programming environment. And if you do, you might recognize things like the forms interface and some of the tools that are being used here. But we're basically building a GIS from scratch using Spatial. And there we have the end of, so two different software tools were built using the Spatial environment. And I'm going to pause it right there for a moment because I'd like you to see that this library is out there and it's available. Visual Studio has recently been released as free for anybody to download and use to develop tools on. Microsoft has released a free version of Visual Studio. I wish they had done that years ago, but it's there now. And you can use our Spatial programming environment to build a GIS application using that Visual Studio. So going back to the PowerPoint here for a moment, this is the YouTube video. But you might be saying, yeah, is that really open source? I mean, we hear people call things open all the time. How do you know if it's truly open source? Well, I have a pet peeve. My pet peeve goes like this. Hey, Dan, our software is open source. If you want a copy, email me and I will send it to you. That's my pet peeve. True open source software should be accessible like this. Anyone, without emailing me, should be able to go find it on GitHub or an equivalent open source code hosting repository. So here we have the GitHub website for Spatial, and you or anybody who is interested in building their own GIS-enabled app can download Spatial here. So you can clone it, you can download the source code that actually builds all of those tools, or you can download the compiled binaries like the DLLs. You can download those and use them directly in your application. So don't be hornswoggled by somebody saying their software is open source when it truly isn't. To be open source, it ought to be out there, freely accessible and ready to grab and use by anybody. So I'm pretty pleased with Spatial, and I'm excited to share that with you and let you know that it's there and that you can use it. Let me know if you have any questions. You can always email me and I'll talk to you about Spatial. In fact, when we're done with this presentation today, I will be up late tonight working on a Spatial application I'm building at the moment. Another application, if we shift gears a little bit from the desktop side to the web, I'd like to highlight the HydroShare environment. HydroShare is a new sort of YouTube for water data that's being built in the US by the National Science Foundation and a large team of universities. HydroShare involves data and metadata, and very importantly, it involves apps. Well, let's define this word app a little bit more precisely. If you don't mind, I'm going to take some liberties here and try to, I know every one of you has a telephone in your pocket. You know what an app is, but I'm going to take a liberty and try to define it for you a little more specifically. An app is generally a single purpose, self-explanatory, modular piece of software. It's usually presented in a portal, installable, removable, and can be independently developed. And this is a very important set of distinctions. I'll show you why. Here is my Samsung Galaxy phone on the left and an iPhone on the right. There are a number of apps in there. Do they meet these criteria? Yes, they do, and we'll see why. Here is another app portal. This is the new app portal we've developed at BYU that I'm introducing to you today. It's called Tethys Portal. In Tethys Portal, you can click on an app and launch a separate app that does something, such as this dewatering tool. Now, you might be saying or asking yourself, wait a second, isn't a web app basically just a website? I would argue there's a little bit of a distinction, and the distinction goes like this. Here's another website that does something similar. This is a US Geological Survey mapping website where you can go and look at old maps of the Mississippi River system. Now, this top one is a website and the bottom one is an app. Why? Well, the top one is single purpose and self-explanatory. It's very easy to use. It only does one thing and it does it quite well. The difference is it is not modular. The top one is not modular. It's a website. It's not presented in a portal where it can be launched separately from other apps. It's not installable or removable, and it's not independently developed. It was developed by the USGS. So think in terms of how your iPhone or your Android app differs from a website. And this is where we're trying to get to with this apps paradigm that I'm sharing with you today. This idea of building web apps that live independently in a portal, can be put in and taken out, and do open geospatial stuff. So what is this framework? Now, quick check. Okay, I see smiling faces, so that's a good sign. That means hopefully you can still hear me. Awesome, thank you. So what is this Tethys platform? What is this app platform that allows us to do this kind of web app portal? It's called Tethys, and Tethys is briefly a stack of open geospatial software tools that are all smashed together to make it easier for you to develop these open web apps. Some of the tools include GeoServer, you may have heard of that, or 52 North. PostGIS is a spatial database. It includes access to some Google products as well as open layers and high charts for graphing. It includes something called HT Condor. This is a backend tool that allows you to parallelize processing on your server. It includes access to Windows, Azure, and Amazon Web Services. All of this is for cloud or distributed computing. And it includes access to data storage. So we've taken as many of these nice open access, open source tools and some commercial tools and smashed them together into an environment that gives you the ability to fairly easily build and launch web apps. An important concept here, the back end. If you look on the second bullet from the bottom, the back end is all Python. And that's great if you're interested in GIS, because a lot of GIS people know Python. So all of your modeling, all of your data analysis is Python. The front end is JavaScript and HTML. And the front end is also, it's modularized, sort of like the .spatial thing I showed you, where you can bring components in and make them work together. But here we're doing it in the web. So again, what is a little more about what is Tethys Platform? There's a data model. It largely uses PostGIS. The controller code uses backend Python, and the views are all sort of Django and gizmos and widgets and JavaScript, HTML. This slide is meant for the computer scientists out there who understand the model, view, controller approach to software development. So you can learn more about Tethys Platform at tethysplatform.org. Again, all of the source code for Tethys Platform is available on that website. So this is a nice open source project, and there's a community that's growing around tethysplatform.org that includes some government agencies and commercial companies and a number of academic institutions building apps. The source code for Tethys Platform is on GitHub. And the documentation is available using a tool called Read the Docs. Unlike many open source software tools, Tethys Platform is actually fairly well documented, which is why I put an exclamation point right here. So in order to use Tethys Platform, you need to have a website, and you need to have kind of a way to build apps and a place you want to host these apps. We've taken Tethys Platform over here on the top right and tied it to the HydroShare data sharing environment I mentioned briefly a few minutes ago. And I just want to show how this works. It's kind of cool, actually. The idea here is that HydroShare has a definition of a resource called an app, and there's metadata stored with that resource. And part of that metadata is how to find and launch that web app. If it helps, you might think of it, and this might only help the older people in the room. Sorry for you younger people. You may not recognize that thing in the background. That's a card catalog that used to be very common. So think of these app entries here in the database as basically a card catalog entry to the apps themselves, which are sort of like the books that get run. And these books exist in multiple forms. There's the official Tethys apps that we are building for this National Science Foundation HydroShare project, and also third-party apps that are sort of like websites that can be launched. And these card catalog entries can launch any one of these kinds of apps. Just to drive home my comment about what is a card catalog, here's a picture of an actual card catalog card that would have been filed in those drawers. I can see some of the younger people in the back of the room are smiling because you've never had to use one of these. But this is the way we used to find books in the library. Well, you can think about all of this information as metadata that will help you find the app you're trying to launch. And in HydroShare, we store metadata such as the app title and abstract and keywords. And then we have some extended metadata such as how you actually launch the app. What's the URL? What's the version number, and so forth. So for example, this is a little technical, but in this HydroShare environment, we can launch our web apps and pass into it a resource. For example, we have some nice data sets sitting in HydroShare. We can launch a web app and say, hey, use this particular resource ID of a particular data set to show that web app. And I think it might be better if I just do this by example. So here is hydroshare.org. I'm going to bring it up in a browser. So I'm smashing multiple technologies here together now for you. HydroShare is the data storing environment, and Tethys is the app environment. So I've launched HydroShare. I'm logged into it now. Hydroshare.org is free for anyone to create an account and store data. I've actually stored a number of small data sets and resources inside HydroShare here. But I can also discover resources that other people have put inside HydroShare. And some of those resources include spatial data. So if we scroll down, we'll look at filtering these resources by type. And let's look to see any Esri shapefiles that have been posted in HydroShare. It's quite a few. And we could search these a little bit deeper if we wanted. For example, I'm interested in any shapefiles associated with Logan, Utah. And here we find some hydrologic terrain analysis for Logan, Utah. And okay, so what I was saying is that it's knowing that it's dangerous to do live demos of web apps. I've talked to you a little bit about some of the open source tools that we've been involved in building and what we believe constitutes a web app resource, and how such things should be. Did you get this? Did you see this stuff?
Yeah.
Okay, great. So I'm going to end with a little video highlighting some of the apps we've built. And as you watch this, it's not to impress you with anything cool we've done, but it's to inspire you on the kinds of GIS open geospatial web apps that you could build potentially using this Tethys platform. Looks like this. Okay, so that's sort of the story of web apps and open geospatial tools from.
Hello, it's Daniel Ellis University. I am making a series of videos for my semester in 514 geospatial software.
Okay. That's it. Yeah. So thank you very much. I appreciate your time and appreciate your patience as we do this remotely using technology. Thank you.
Okay. Thank you, Dr. Ellis. That's a really great presentation. I think we have time for a quick questions. Any question? I think I have a question. So this website is mainly focused on hydrology. Do you consider to involve some other fields relevant to the hydrology, such as meteorology or biology, something? I mean, I don't mean too much, but a little bit maybe.
Yeah, good question. Good question. So there are a couple of ways to approach that. I guess one is to think in terms of the Tethys platform for building web apps. All it is tying together open source GIS, PostGIS, open layers, all of those different technologies. You could build apps for any purpose, I suppose, outside of water. We apply it in water quite extensively. The other side of that question is the HydroShare part for storing the data. The HydroShare part, fortunately, all of that code is also open source and could easily be relaunched as meteorology share or geology share, couldn't it? I suppose it would be just as easy. So I guess that's the advantage of working in the open source domain. It's quite nice to be playing in that domain. The other question that should come up, and often does, is how can you sustain open source software? How is it sustainable? Because you should have commercial companies. And my point is that when you look at all of the commercial apps, like the Google and the different ones, a lot of them pump money into open source projects to help sustain them. So it is doable. And we've seen that already with the Tethys web app framework. People are starting to support it and use it in different companies and government agencies too.
Okay, thank you, Dr. Ellis.
Hey, thank you. It's been a real pleasure to be here. And I'm sorry I can't be there in person. I'll disconnect and I'll watch for a report on the conference. I'm sure your student promised me to send a full report.
Yeah.
A complete and full report. I expect lots of details.
I think that's all.
All right, thanks.
Okay, thank you.
Thank you.
Okay, let's move to the second talk. Our second keynote speaker is Dr. Annie Jackman from the Australian